Should I count you in?
Yeah.
Okay, and Alex, you are live.
Good evening and welcome to Power BI User Group, the July User Group session. My name is Alex Taylor, so welcome to any newbies. Tonight we're in for a treat. We've got 3 speakers. We've got Alan, all the way from Croatia. We've got Victor, who is over in Dublin, and we've got Dennis, a Brazilian, who is over in Malta. So we've got 3 fantastic talks. I'll quickly go through my slides before we kick off with our first speaker, Alan. 1 second. So about these groups, so if you're new to these groups, we've been going for around about 4 years now. I've been running all the sessions. Prior to COVID-19, they were live in Manchester. We used to do them every month. We used to get around about 80 to 100 attendees. These are fun networking events, and we've had some fantastic speakers from around the globe. So unfortunately, Victor, Alan and Dennis couldn't fly over to sunny Manchester to this evening to present, but hopefully I'll get them back at a later date to come and see the sites. In regards to the sessions, obviously the sessions have been well recommended. We're getting about 4.6 for every session out of 5. So do review the session afterwards and say if you're happy with it. And I said you can see some of our testimonials just there. Moving on quickly, about me, I am a BI data analytics enthusiast, meetup organizer, but most importantly, I am a data recruiter. So I work in a data recruitment space. I've been recruiting people for over 16 years, solely around contracts, but my counterpart Chris does permanent. So if you are looking for a new job, if you are looking for a new challenge, if you are looking to hire some for your team, if you're looking for information in regards to remote onboarding or salary information, please get in touch. My details are below. I'm happy to help out. And I said, appreciate the market is quite fun at the moment, so I'm happy to advise people on what their next step would be, or if they're looking to bring on someone on a contract, interim or fixed term or perm basis. And so tonight's agenda, after I've finished my little chat, we've got Alan Skuga, who's over in Croatia, and his talk is all tricks with all functions around DAX. Then at 6:45, we'll be moving across to Victor Rodriguez and his topic on monitoring refrigerated trucks using IoT Central and Power BI. And then our third and final speaker is Dennis Torres, who'll be doing self-service ETL, Power BI Data Flows. So it's a fantastic talk tonight. I hope you enjoy it. Do put your questions on the right-hand side Q&A. Any questions you have for our 3 speakers, we'll do our best to answer them. My co-host, Celine Sheb, will be on the Q&A to answer the questions. And if he can answer them, he will do. If not, we'll push them out to our 3 speakers. So a little bio about our speakers. So Alan is an experienced BI consultant with a 15 years experience. He'll probably do that in an intro in a minute, but he started in Power Pivot and later in Power BI, and he's founder of a company called Bit and Bit, which is dedicated to Power BI education and implementation. Victor is a Azure cloud specialist for the application modernization, data modernization, IoT, machine learning and AI. He's got 10 years experience. As I said, he is working in Dublin at the moment, living in Dublin as a Storm Technology Azure cloud specialist. And our final speaker tonight is Dennis, as I said, he's a Brazilian living in Malta who loves BI SQL development with over 20 years experience, and he's been leading the Dev SQL PaaS chapter in Rio, and now the Malta chapter recently. He obviously is working across various different projects, currently working for Ascent Software, and has spoken across various different events, including SQL Saturday. Without further ado, can we move across to Croatia? Alan, how are you?
I'm fine, thank you. Thank you, Alex, for the invitation. Manchester is a very beautiful city, as I see.
It's a gorgeous city. I'm in South Manchester, where hopefully we'll have you over to Manchester for a later date, and I'm sure there'll be some fantastic events coming in the next few years.
Yes.
Thank you very much for getting involved tonight. Please, can you share your screen so we can get your slides up?
Yes. So here's my screen. So thanks. So my title of my presentation is All Tricks with All Function. To be honest, I will not talk about all tricks. It was just a funny wordplay to have all tricks with all function, but I will talk about few tricks, and as a matter of fact, it will be exactly 3 tricks. So I will have a small introduction, then I will talk some basic things about all function, and then I will talk about three cases, three puzzles I came across during my work with Power BI in the last 8 years. And strangely, they are all connected with this very easy function, all. Okay, so my name is Alen Škugor and I come from Croatia. Here is a typical picture of the most famous city in Croatia. It is Dubrovnik, especially after the Game of Thrones was filmed there. So I'm working with Power Tools since 2012. At that time, it was Power Pivot in like add-in in Excel, and 50 years of experience in telecom industry as financial controller. But last 4 years, I'm focusing only on Power BI in my own company, bit and bit, as Power BI trainer and consultant, helping other organizations to implement Power BI solution. So 8 years ago, when I started to learn Power BI and especially this DAX, I learned almost like Excel, mostly from trials and errors. I didn't have some books, I didn't have web content so much like now. So, and often I thought I understood everything. And later in working with Power BI, I saw that my knowledge is not so concrete and firm, that I have gaps in my knowledge. And one of the easiest function, all, makes the biggest troubles in my reports. So this presentation is a story about when I was 3 times puzzled with this easy function. So prerequisite to follow this presentation is familiarity with all function and with filter context, with data modeling. And Q&A session I will answer at the end. So firstly, some basic things about all function. All function is actually 2 different functions. We can have all as a table function and all as a filter modifier in calculate. So when we use all as a table function, it returns always table. It could return whole table, or it can return only unique values in one column, or it can return unique combination of values in set of columns, but it always returns a table. And when we use all as a filter modifier in calculate, then it doesn't return table. It just removes filters from table or columns, or in other words, it removes filters from filter context. And in that second case, we have alternate syntax when we can replace all with remove filter. So that's totally the same function. Remove filters sounds better because it really says what it does. So it removes filters. So we can use both all or remove filters. And in this presentation, I will talk only about this second case when we use all as a filter modifier in calculate. So the basic syntax is simple, and it's the same for all and for remove filters. So we can have 2 types of arguments. If we have table as argument, then we can have only one argument, and it removes all filters from whole table. Or we can have columns as arguments, then we can have more arguments, and it removes filters from those columns. Okay, so that is some basic facts about all function. Now we will go to this first case, first puzzle I came across. Let's say we have this very simple model. We have on the right side of the screen, we have one fact table and 3 dimension tables. So fact table is F sales, and dimension tables are D date for dates, D shop for shops, and D fruit for fruits. And we have 3 kinds of fruits: apple, oranges, and bananas. We have 2 shops, shop A and shop B, and several dates. And what we want to do this small visual element on the left side. It's one table where you can see for each fruit what is quantity sold and also what is share in total sales. And in order to calculate this share in total sales, we have one additional column. It's called quantity total. And we can easily then calculate share just by dividing. So we divide quantity with quantity total to come to calculate this share. And how can we calculate this quantity total? By using function all. So this all clears filter from column fruit, and that's why we have total, in this example, 1,870 quantity in each row. It just repeats the total because this filter on fruit column is cleared. Okay, so we will do that now live in my Power BI report. And in order to do this quantity total, I will make a measure with this DAX expression. So quantity total is calculated with two arguments. First argument is expression, sum of quantity. And the second argument is clearing of filters from column fruit. Okay, now I will skip to my Power BI. So I will just quickly go to this data model. So you can see this is one fact table, 3 dimension tables. Okay. And now I will create table, one visual element, and I will put inside fruits and quantities. Okay. And I will increase a little bit those fonts because it is probably too small for you. So I will put 15. Okay. So that was pretty easy. And now I would like to calculate this measure quantity total using calculate and all. So new measure. And quantity total equals calculate. First argument is sum of quantity. Second argument is removal with all, removal of filter on fruit. Okay. And so that's that measure. So I should now have the same number, 1,870, in each row, like on this slide. And I will now put it in my table. But strangely, it doesn't work. So quantity total should be 1,870 in all 3 rows. And why it doesn't work? So that was I came across it a few years ago, and I was sure. So it's probably some bug because I understand this all function very good. So it's not it's some kind of bug, or not, or is my knowledge has gaps. So what to do? Let's copy this table to the right, and let's inspect a little bit. So why it doesn't work? So what can I see? So I put a column fruit from fact tables. It says F sales fruit. So this is from fact table. And when I look at my measure quantity total, I apply all on fruit from dimension table. So now I will just show you, maybe it's more clear when I show you here on data model. So we have 2 column fruits, 1 column fruit in fact table, 1 column fruit in dimension table, and they are connected. So they should act like 1 column. And okay, maybe let's try. I don't know, maybe I will just remove this fruit from fact and put fruit from dimension table. And now quantity total strangely work. So how's that? So, or how's that it before it didn't work? So why it didn't work in this first table? So what was my, let's say, beliefs and knowledge at the time? I thought that when you have 2 columns, fruit in dimension, fruit in fact tables, and when you connect it through this relationship, then those 2 columns become as 1. And when you filter 1, let's say fruit from dimension, fruit from fact will also be filtered. Or vice versa, when you remove filter from fruit from dimension, you will also remove filter from fruit from fact. So I thought they are connected, and that's, but it seems that they are not connected. So you can see here, I removed filter from fruit from dimension, but it still isn't cleared. So it seems that it doesn't clear fruit from fact. So So my beliefs over this: are those three statements true? When columns are connected to a relationship, they become like one column. If the column from dimension table is filtered, of course the column from fact table is also filtered automatically. And it's enough to remove only one filter from one column from dimension table in order to remove filter from fact table. But is it really true? So that was my, let's say, question a few years ago. And later I knew, I've learned that first thing, what does it mean to filter something? We have two kinds of filtering. We have cross filtering and direct filtering. So what is the difference between those two? So let's say we have this data model and we have this small table. If I put in this visual, in this table, if I put fruit from dimension table, then this column from dimension table is directly filtered. Why? Because we have this column in our visual element in our initial filter context. So that's why it is directly filtered. But this column also, for sure, filters fact table, removes some rows from that. So all this filtering is cross-filtered. So we have only one column which is directly filtered, and all other filters columns are cross-filtered. And what does all do? All, as a function, removes only direct filter, not cross-filter. So I cannot say, please apply all to column quantity, let's say, and with hope that I will have a total quantity. It doesn't work like that. So all doesn't remove cross filters, it removes only direct filters. And I should, in order to clear, let's say, quantity, I should seek and find every direct filter across the data model and remove it with all, each one by one. Or just another case where we have here, I will put now fruit from fact table, into visual. And now this column is directly filtered and those other columns are cross-filtered. And again, all removes only direct filter, not cross-filter. Okay, so if we want to apply all, so we should firstly know what is direct filtered. And how can we know what is direct filtered? So all those things which are on visuals, but we have also one DAX function, which is called isFiltered. And this function checks whether some column is directly filtered or not. So I will now make those two measures. So first measure is F sales fruit filtered, and equals, I just put is filtered, and I will put this fruit from fact table. So I'm checking whether fruit from fact table is filtered. So that is this measure, and it will say true or false. So I'll put this measure in the first table where I have fruit from fact table inside. So of course it is true, true, true. It is filtered because I have the same column in this table. Okay, let's make the same thing with the other table. I will put now that, and now it's false. So that was my. Previously I thought that it will be true. Why true? Because so here we have fruit from dimension table. So if we apply filter on fruit from dimension table, it should automatically apply that filter to fruit from fact table. And it seems it doesn't work. So here I can also check this other dimension from, I will make another measure which tests fruit from dimension table in the same way. So is the fruit filtered? Again is filtered, but this time I will put fruit from dimension table. Let's see, is that filtered? And so I can see that fruit from dimension table is filtered, but fruit from fact table is not filtered. So that was something new for me. I thought that because this is in dimension table, of course, when this is filtered, the other down is also filtered. But it's not true. So those statement, this is true statement. So columns in relationships are still two different columns. It's not one column. So they are connected, but they are still two columns, two different columns, cross-filtering the same table. And each of them can have its own direct filter. It's not that one filter is automatically applied to other, but each of them can have its own direct filter. One can be filtered, second not, vice versa, or both can be filtered with different filters, or none will be filtered. And to clear both direct filters, both columns should be cleared. So there is no automatic clearing by removing direct filter only from one column. Okay, so let's look again at this table when I have fruit from fact table in our visual. So let's look at field, let's say 580. So what is the filter context in this field? Apple. So fruit is equals apple, and this filter goes further in a way that it selects and filters only those rows where in column fruit we have apples. And so this column is now directly filtered, and the quantity is then cross-filtered. And that's how we come to this 580. And which columns are now filtered, which not? So fruit from fact is directly filtered because it's in visual. Fruit from dimension is not filtered at all because it's not on the visual, not on the, let's say, filter propagation path. And quantity is cross-filtered. And does it make sense to put all, to apply all on fruit from dimension? So that doesn't make sense because fruit from dimension isn't filtered in the first place, so it doesn't make sense to remove filter from column which is not filtered. So that's why in this first table, our quantity total didn't work. So it's the same like quantity. But in the second table, when I put in my table dimension from fruit from dimension table, and if you are looking at the same field 580 where we have a filter context apple, this time fruit from dimension is apple. What I thought before that this direct filter automatically go to that it will direct filter fruit from fact table, and then this column will then filter quantity, but that's not true. So that's not true. That's not what is happening. Because this fruit from dimension table automatically, so it doesn't copy direct filtering on fruit from fact. It just cross filter whole fact table. How we do it? It just so we have one technical detail here that this dimension column from dimension has its own shadow in fact table. And then we call, then we talk about expanded table. What is expanded table? Expanded table is, we have in expanded table all columns from fact table and all columns from related tables. So in that sense, we can see like some shadow of this fruit from dimension in the fact table. And this is directly filtered, and this cross filters this quantity. So that's the path how it is cross filtered, and the result is 580. The important thing is that fruit from fact is not filtered. It's not directly filtered. So it doesn't mean that when fruit from dimension is filtered that automatically fruit from fact is filtered. So in this case, we can see that fruit is not directly filtered, but it is cross filtered, while fruit from dimension is directly filtered and quantity is cross-filtered. And here it makes sense to apply all to the fruit from dimension table, because exactly this column has direct filter, and then apply, then all can remove this filter, and that's why quantity total here is correct. So we have 1,873 times in all 3 rows. So that's the so what is the recommended solution? We should use always the same columns in Visual and in DAX, not to mix, to put one column in DAX and another in Visual. So you should use always the same, and the recommendation is that we use always from dimension tables. And this dimension columns from fact tables should be always hidden, and that's the best practice, especially when we have several facts or when we have more facts than one. Then it's must. Okay, so that is my first puzzle. Second puzzle is again with the all function. Again, we have just a second. I will just close this first and open while I'm speaking about second. I will open the third one. Okay. Okay, so second one. Again, we have one model, which is very simple. I have only one fact, again, F sales, and 2 dimensions. This time, in fact, I have business segments. I have 4 business segments. I have SOHO, VSE, SME, and corporate. And they are sorted according to number of employees, not according to alphabetic order. That's why in this table, this segment, I have 2 columns. I have one special column sort in order to have this special sort according to employees, not by alphabetic order. And the goal is the same like in previous case. I would like to calculate this revenue total using function all with calculate. So let's do that. I will go to the second, and I will make table. And now I've learned. So now I will not put dimension from fact. I will put dimension from. I will put segment from dimension table, and revenue from fact, of course. And I will increase a little bit those fonts. So let's say 15. 15. Okay, and now I would like to calculate again this measure, revenue total, in the same way like in previous case. So revenue total equals calculate. First argument is sum of revenue. Second argument is removing filter from segment, but from which segment? From segment from dimension table. So in that case, now I've learned I have the same column from dimension table in DAX expression and in Visual. So now it should work. So now this revenue total should 100% work, but it still doesn't work. So what's now? So now this time it is really bug or what? Because now I think that I understand all function and I take all precautions and now again it doesn't work. So that doesn't mean that all conclusions from first case are not correct. Here we have some extra thing. So what? Let's put again. Let's calculate these measures which checks whether something is filtered or not. Okay, new measure. Is segment filtered? Is segment filtered? Is filtered. Segment from dimension. Okay, so is it filtered? Of course it should be filtered because we put it in this visual elements and it should be filtered. And when I put it, it says true, 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 true. Okay, so that's correct. But how come that when I have this my measure where I put all So I applied all on this exact column, and I remove this filter, direct filter, and it's still revenue total is not in total, but it's like filtered. I don't know from which column, because I don't have any other column here. So how come that it's still filtered? So that is really a big puzzle that was for me. And I see that I have another column in this segment, dimension table, sort, but this sort is never mentioned in visual, so it's not filtered. So okay, I can check. I can make also one measure checking is sort filtering, is column sort filtered. So is sort filtered, shouldn't be, but let's say we are debugging. So sort, okay. And it should be false, false, false. Oh, but it's not. It's true, 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 true. So how come that this column is directly filtered and we don't have it anywhere in our visual? So that's really, really strange. Also, it seems like bug or something, but that's some gap in my knowledge. So there is exception when sorting by column. So what I did, I told you before, let's check it here. I told you that I don't like to have business segment sorted alphabetically. I would like to have it by this sort. How I did it? I click on business segment, and here I have sort by column, and I just click sort. So by default, every column is sorted by itself. But here I explicitly said that business segment should be sorted by another column, by sort. And it seems that that is some exception. So when I go to presentation, so it seems that this sort by column is guilty. Why? So after sort by column, those two columns are like connected. And if I filter segment, automatically column sort is also filtered. So that really happens now automatically. But on the contrary, when I remove filter from segment, filter from sort is not automatically removed. So it's, let's say, a very strange thing. But now it's clear how to solve it. So I should just explicitly remove filter from this column sort. And I can do it just by expanding this. I will add third argument in calculate where I clear filter from this column, or I can just say, please remove filter from whole dimension table, this segment, and I will do just that. So I will go to this example, and I will just remove this column. So it's now not only removing filter from this column, but it's removing filter from whole table. And when I click OK, this revenue total should now be OK. Let's hope so. Working on it. Sometimes it's not so fast. OK, so we can see now revenue total is really OK. So that was some gaps in my knowledge before and some exceptions, which are maybe not so well known. Okay, and then we come to the last puzzle, to the last case, which is data model is totally simple because we have only one column, only one table, and that's date table. It's not even fact table. And what I would like to do, I would like to make 3 slicers, year, month, and day, and select, let's say, today's date. And I would like to calculate 2 measures. One measure, max date, should calculate maximum date selected, in that case 29th of July 2020. And another measure which will calculate previous day of that max date, that's yesterday, 28th of July. So that is my goal. And DAX expressions are very simple. So max date is just max from column date. And this previous date is again using calculate and filter modifier, this time dated, not all. What does dated do? It takes date column and moves it 1 day in the past. So I will do that. I will go to the third example. I have already here, I have those three slicers. I will select 2020, select 7, and let's say select 29, or even I can select 28, 27. And now I will calculate firstly this max date measure. So max date equals just max from column date. And I will put it in one special visual element, which is called card. Okay, and I will just format it in order not to have those hours. Okay, so that is our max date. And it's, of course, it said 29th because 29th is the maximum date. Okay, now I will do another measure, this second measure, which is called max date previous day. So max date PD, previous day. And we use calculate in order to modify filter context. First argument is max date. Second argument is filter context modifier, this time dated, which modifies only one column, that is date. And the second argument is -1 because we would like to go 1 day in the past, so day. Okay. And when I put this measure in my card, it works perfectly. I will just remove these hours, and we can see that previous day is 28th of July. So everything works fine. And then I suddenly, accidentally, just played a little bit with this slicer, and let's say I click select only 29th, blank. Max date PD is blank now. There is no sense. So this is again some bug, because I have max date 29th and previous day is 28th. Why? The max date is the same as before. If I click 28, then it appears. So there's no logic, because max date is always the same and previous date of max date should always be also the same. So again, some strange bugs or lack of my knowledge. So let's inspect a little bit. I will copy this page and I will delete those three slicers. Or Alan, I will, excuse me?
Alan, we've got a 10-minute warning, mate.
What you said, we have 7 more minutes or?
10 more minutes.
Okay, 10. Yeah, good, thank you.
Catch you soon, thank you.
Yes. So I will put date in this one slicer. And when I put date and I will select, I don't know, any date, now it works. How come that this max date PD previous day now works perfectly? When I click any date, it works, or if I click several dates, it works. But on page 1, if I click just one date, it doesn't work. And here it works. So that is very strange. How come that just number of slicers is important? So let's look at presentation. What could be here? So let's inspect a little bit. So this first situation, when I had year 2020 and month 7 and day 29, so initial filter context is year 2020, month 7, day 29. And when I apply dated modify filter context on date column, not on year column or month column or day column. It modifies date column in a way that it moves 1 day in the past. And after this, we have not 3 filter in filter context. We now have one more. We have 4 filters in filter context. So we have year 2020, month 7, day 29, and date 28th of July 2020. And what is the intersection of those 4 filters after logical end? It's empty set, because there is no row which is simultaneously day 29 and date 28. That's why this max date previous day is blank. So it's totally normal. It's not bug. It's not error. And on the second slide, what is happening when I put when I select 28 and 29? Now, in initial filter context, I have 28, 29. After calculate, I have fourth filter added, 28th of July. But this time we have intersection because we have 2 days, 28 and 29, and there is intersection, 28th of July. That's why this time is not blank. And this third example, when I didn't have a filter context on year, month, and day, but I had on date, I have only one filter in filter context, 29th, and after filter modification on that same column, I have 28th of July, and everything is fine. So there is no errors in all those 3 cases. I have just this ugly blank, and I can very easily remove this ugly blank. How? Solution 1 is I should just remove these filter context from year, month, and days. And how I can remove it with adding this all the date. I will do it now. So I will just take this max date PD, copy it in order to make max date PD2, that you can see the difference. Oh, sorry, I didn't copy it. Sometimes it happens. Just a second. So Control A, Control C, new measure. Okay, so this is, and I will just add this one additional clearing of all filters from this date table, but leaving this date add. I still have one filter in filter context. And now when I put this, I will just go to the first page in order to see this blank. When I put this and to the, let's say here, this max date PD2, now this works. So it is very easy to correct this blank, just to put this small third argument, all the date. Okay, there is just a few other solutions. I will quickly show you. Solution number 2, but date add always worked, even without all date. So we use this date add hundreds of times and never put all date. Why we should put it now? So we shouldn't put it if we connect the date with the fact table. So if we have a relationship between the date, dimension table for time, and some fact table, then engine automatically adds all, this all which we put manually. Engine automatically adds all to DAX expression whenever date is referenced. So I can quickly show that. I will just, I have here one fact table, it's hidden here. I will bring it here. And I will just connect date to date. And after this relationship is made, you can see that this middle one started to work, 28th of July. If I delete this, then it will be again blank. So that is second solution, it's blank. And last solution, third solution is just to mark this date table as date table. How I can do that? I can just go here, and here you can see mark as date table. I click mark as date table, and it will ask me in which column I have date. Here it is, okay. And after a few seconds, this again works. So we can see that we have 3 solutions, and second and third are very often used, and this first one almost never, because we always have either date table connected to fact or mark as date table. So that's my third case, and the conclusion is just to repeat, let's say, those 3 sentences. From first puzzle, 2 columns connected to relationship are still 2 columns, and each of them can have its own direct filter. And by removing filter from one, the other is not removed. Then second case, we have some specialty about sort by column. Column sort is connected to that column, filtering that column, sort is automatically filtered, but both columns should be addressed for filter removal. And in this third puzzle, we have this when engine automatically adds all to the DAX expression whenever date column is referenced. if it has a relationship through date column or is marked as date table. But if it's not, then we should do it manually, which is very rare. So thank you for attention. And I'm wondering now, is there some Q&A? I think there is no questions.
No, Alan, we're okay for questions. You like to end your content and I can get Victor on screen.
Okay, so I will exit my stop sharing.
That's the one. Perfect. Hi, Victor.
Hi, how are you guys?
I'm good, thank you. You okay to start sharing your content?
Yes, let's go. Second screen. Yeah, it's here. Okay, you can see my screen, yeah?
You are good to go, mate.
Okay, so first, thank you very much for having me today. Alex, thank you for the invitation. The session today will be a little bit different, I think so, because of the point of view of the user group is more the point of view of the Power BI. I promise there's a little bit of Power BI, but I just want to provide you guys a little bit another overview of other products that we have inside of the Microsoft portfolio. So hello everyone. So I hope you are having a lovely evening today. As I mentioned, my name is Victor Rodrigues. I'm Azure Cloud Specialist for Application Modernization, Data Modernization, IoT, Machine Learning AI at Storm Technology here in Dublin. I'm Brazilian as well, so I moved recently from Brazil to Dublin. I think I'm completing 3 years right now. So my story is really recent around IoT that started, like, say, 2 years ago in Brazil, in a project for VI called Fleet Management System. And since that project, I fall in love with the platform. So currently, I'm doing some proof of concepts that involve smart off solutions and image recognition with the NVIDIA platform. So feel free to connect with me on LinkedIn and Twitter, okay? So today I will walk you through a quick overview of Microsoft IoT product portfolio, what is IoT Central and templates, the solution for monitoring refrigerated trucks, and how to export the data from Azure IoT Central to Power BI for analysis. Let's go. Let's check what Microsoft offers for IoT solutions. So at the bottom layer, Microsoft offers support for IoT and edge device via Azure IoT Device SDK, Azure Sphere, and offering many other supporting services. On the second layer, we have a rich set of platform as a service offerings in IoT services such as Azure IoT Hub, Azure IoT Device Provisioning Service to stick together your solution in conjunction with all other services in Azure. On the third layer, we have the offering on the solution space. Is that what is the really put Microsoft ahead of all other players? The solution offers are Azure IoT Central that we are going to talk today, and Azure IoT and the Azure IoT reference architecture and accelerators. Okay. On the third layer, we have and you can use any of the solutions that I mentioned to build the solution in any kind of industry that you can have, and you can have peace in mind for long term that your solution is secure with Azure Security Center for IoT. Okay, so if you look at the typical IoT solution, you can break it down into things, insights, and actions. And things are the IoT device and edge device and gateways that you have connected to the cloud. On the right column, you see actions column, a set of business applications that actually allowed you to visualize the data coming from the IoT device and take actions based on this data. So many customers, the data coming from their IoT device and take actions based on this data. So, however, if you tried before to build something with the IoT, you know that's entirely untrue, and there's a lot of things in the middle that's actually help make this work. I'll show a little bit more about this in the next minutes. So, many solutions start with IoT Hub. And that's allowed with the bi-directional communication between the device and the cloud and the old set of other services that you're probably going to add, like Azure Maps that they use today, or Azure Functions, or Stream Analytics to deal with the things like hot, warm, and cold storage, or transform your data into form your business application needs. And all these services to manage, and with all these services to manage and to be understand, this is a truly complex let's say, taking to build any IoT solution and to simplify this IoT, simplify this entire solution that we have, the Azure IoT Central. Okay, let me just come back here. Okay, so Azure IoT Central is meant to simplify the production-ready IoT solution. It's a highly secure, industry-focused, and offers a predictable pricing model and take care of all IoT plumbing I was just talking about. So IoT Central is a hosted app platform that's easy way to get your device connected to the cloud. Keep your device connected through the centralized device management, fill and transform your data bridge and the gap to your business application. Along with a core set of features with IoT Central that we launched last year, like edge support, monitoring rule, trigger action, and industry-focused application templates. Now we'll talk about the IoT Central templates. So Azure IoT Central application templates is a tool for your quick start, your IoT development, and really get to that production level of the IoT solution more quickly. For now on, you focus on how you can monitor refrigerated trucks using IoT Central and using the code path to do analysis of the data extracted using Power BI. So let's understand first the scenario. Let's suppose that you run a company that operates a fleet of refrigerated trucks. You have a number of customers within a city and a base that you're operating from. You command each truck to take the contents and deliver to the customers. However, the cooling system may fail or any of your trucks and the content start to melt. You need to have the option of, let's say, instructing the truck to return to the base and then dump the contents. In order to make these actions, you need an up-to-date picture of how it's going on with your trucks. You needed to know the location of each truck on map, the state of the cooling system, and the state of the contents. IoT Central provides all you need to handle this scenario. In the image, you can see here the colored circles show the location of the trucks here on this way to the customer. This is the main dashboard, for example, that we just built inside of the IoT Central. On the other side of the scenario, to be able to, let's say, do analysis with Azure Machine Learning or long-term trend analysis in Power BI, you need to export your data. Let me show you now how the architecture of receiving information and then for further analysis have these on the Power BI. Okay, the scenario architecture here. First, we have the refrigerated trucks as a simulated device sending telemetry information to the IoT Central. Then we have the IoT Central, that's the main component of the solution that put all pieces together. We have here the Azure Maps to provide the map service for the location of the trucks. Then we have the Event Hub as the integration from the IoT Central. And we have the Stream Analytics job to get information from the Event Hub and write to Azure SQL database. Here we have the Azure SQL database that will host the telemetry to be analyzed. And then, of course, we have the Power BI as the reporting tool. Okay, let me go straight away to the demo and show how it works. First, I want to provide you an IoT Central overview. So let's check it out first, the IoT Central. Here we have the main page of the IoT Central. First, let's open the dashboard. So the dashboard display your application dashboard. As a solution builder, you can, let's say, customize the global dashboard for your operators. Depending on the user role, operators can also create their own personal dashboard. So this is the first step inside of the IoT Central. Then we have the devices. Devices enable you to manage your connected device, real and simulated. As you can see here, I have in our device, I have two devices. Both are, one I have installed in my Raspberry Pi, and the other one I just run inside of my local machine. Then we have the device groups. Device group let you, let's say, view and create logical collections of device specified by a query. You can save this query and use the device groups to the application to perform, let's say, the bulk operations. Here I have just all refrigerated trucks here, and you have my all devices here. And you can run queries here. We can delete the devices, things like that. Then we can jump to the rules. So rules enable you to create and edit rules to monitor your device. Rules are evaluated based on the device telemetry and trigger customizable actions. For example, if you can create a rule here to trigger, let's say, every time something happened with, we selected the telemetry, you selected the aggregation, equals, and you can just set the rule here. So every time this happens, you trigger some actions. For example, we can say that every time the temperature or internal temperature of the refrigerated truck reach, I don't know, 5 degrees, you can just trigger an action to send some message, to turn on the refrigerated truck, to do any kind of troubleshooting. So it's really helpful, the rules here. Then we have the analytics here. So the analytics let you create a custom views on top of the device data to, let's say, to derive insights from your application. So I know that I talk about the Power BI, so I'll be there in a minute, but you can do things here with the telemetry that is just being sent by the devices currently. So if you have in contact with this kind of dashboard before, so you know that you can do any kind of analysis using this one. Then we have here, let's say, jobs that enable you to manage your device at scale by running bulk operations. So the jobs acting the same way, so I can select my devices and I can set, let's say, a property inside of the device. For example, optimal temperature to check if we are inside of the baseline, things like that. And then here we have the device templates. Here the device templates is where you create and manage the characteristics of the device that's connected to your application. And here we have data export. So data export enables you to configure a continuous export to external services, such as storage account or event hub or queue. So there's a new one here, Azure Service Bus Top. That's really nice. And here we have the administration. The administration is where you can manage your application settings. You do the customization, add images, your branding, billing, users, and roles. So you can see here the service prices, the hosts, users, device connection properties, API tokens, so everything that's related to the administration of the IoT Central. Okay. Okay, so let's jump now to my trucks. So here I have two simple codes that we have these inside of Microsoft simple codes. I will not walk you through the code today. Just you can check it out. I'll leave this on the resource. But basically, what we need to pass to this work, this is a .NET application running my computer. So basically, we just passing the primary key here and my Azure map key because I want to send the location that my truck it is, and that's it. So I have two devices here. So this one is the first one, simulated device, and I have another session of the Visual Studio here as well. Okay. Okay. So let's leave this running. So I will type .NET run here. I hope everything works. Okay. First one's running. Let's put the second one to run. Okay, connected. So as you can see here, I have some telemetry being sent through the IoT Central. So what I'm sending here basically is the device ID, the content temperature, the truck state, if it's ready or not, the cooling state, the content state, and the location that I'm right now. So jumping back to the IoT Central, we can just come here. Let's say that I'm operator of these, let's say, refrigerated trucks. So I open the first one here. So my truck state is ready, no events happen, the cooling state is on, and send already my temperature here. So I want to say to my truck now to deliver. So I put like my customer ID, for example, here. I will send the truck in 1 to customer ID 2. And I will send the truck to the customer ID 4. Okay, just wait some seconds. Come back to the dashboard. Okay, so the truck 2 is already en route. Let me check the truck 1, what's going on. It's ready. No. Stay again. Let me check what happened here. En route, okay. And the second, okay, there's a fail to find the map here. Okay, that's fine. So doesn't matter. We have the truck is running right now. So as you can see here, even with all the features that we have here in the IoT Central, is really accelerator that you can easily have your IoT application quickly and easy implement inside of the cloud. Even with that, that's some gaps in the implementation that we are going to cover today. So, but yeah, let us say, so the problem is with the IoT Central that we can just analyze the information from the last 30 days. You just keep the last 30 days information. So to do other kind of analysis that I mentioned before, for example, predictive maintenance, anomaly detection, or troubleshooting is required to export the data. The feature to export the data is really simple. We can come here to data export. And as I said, we have 4 types here of export. We have Azure Blob Storage, we have Azure Event Hubs, and we have Azure Service Bus Queue and Azure Service Bus Topics. So today I'm using the Event Hub. So basically the information that's being sent for the trucks are arriving inside of the IoT Central. And from there I have the data export that you send the same information, just the telemetry, back to the Event Hubs. And from there we start the old, let's say, workflow of this information until arrive inside of the Power BI. The configuration here is really simple to connect to Event Hub first. If you are using the same Event Hub inside of source subscription, you can simply select here. And if you're not, you can just simply pass the connection string. And the connection string, of course, you pass your key. Since I'm using inside the same subscription, here already hiding the information here. Here I have the Event Hub that I'm using, and I just need to flag some stuff here. For example, I'm just sending the telemetry. So I will just enable and click Save. So basically the Event Hub is responsible to capture the events sent by the IoT Central and retain this. From here, you save these events on the storage account or process the data, and we're going to process this data using the Azure Stream Analytics. Okay, let me open the Stream Analytics here. Okay, so Azure Stream Analytics get the input, in this case is the Event Hub, as you can see here. So I have the Event Hub, I have the Stream Analytics connected to this. And the output here, I'm selecting the Azure SQL database. It's totally fine, it's totally quickly and easy to use the Stream Analytics. If you use it before, you know what I'm talking about. If you never use, it's really simple. So what you will have 2 options here. For example, you can add a stream input that can pick information from Event Hub, IoT Hub, or Blob Storage, and you can use a reference input, let's say the information that you already stored. So for example, a Blob Storage or a SQL database. And here we have the output. The output is really simple. So you can select our Event Hub. So where I'm sending information, I can send this back to Event Hub for any other analysis, SQL database, table storage, Cosmos DB, and directly to the Power BI service. If you needed information analysis like near to real time, this is your option using the Power BI here. Okay, so and another part that's really interesting here is the query. So you using here query-like language, so that you can do any kind of transformation here before they write information back to your data source. In this case of the SQL Server, in my case here, I'm just doing some transformations here. For example, I'm getting the location. I'm getting the renaming this column here to timestamp and things like that. But the most interesting part here, a part of these like aggregations and transformations that you can do, you can run some kind of machine learning. There was a built-in machine learning running in Stream Analytics that you can use to run for things like anomaly detection. It's totally applicable for this case that we talk about, the anomaly detection, because I can check, for example, the contents temperature. So if an average is something between 1 and 5, if everything that's away from this, we can just say the anomaly detection, say, do you have a problem here? Okay, we have everything in place. So you have our trucks running. We have the connection made with the Event Hub. The Event Hub connected to the Stream Analytics. Now we just need to come back to the Stream Analytics and start the job. So let's start the job. Let's wait a few minutes. Let's check the status of the truck is running. So if I come back here to the trucks, let's see the Refrigerated Truck 1. Take a look at an overview. Okay, it's ready. The cooling system failed. That's good. Let's send this to the customer ID 8. Let's check the Refrigerated Truck 2. What's happening? Okay, it's ready. It's already delivered something. Let's send this to customer ID 1. Okay, let me jump back here. Wait a couple seconds. Okay, melting. So we have a problem here with the truck number 2, but it's in route. Truck number 1 is still ready here. Okay, so let's check now the Stream Analytics if it's running. Look like everything is fine. Is starting the job. Let's just wait a few seconds. So if the job is running, what's happening right now is the information that is being sent from my code here is sent to the IoT Central. The information on the IoT Central will be arrived there, and then we send to Event Hub. The Stream Analytics will collect the events and write this to the SQL database. So let's check here. So here I have a simple SQL database, Azure SQL database that's connected, that is receiving the information from the Stream Analytics. The last ID that I have here is 1398. Let's check if his new information is arriving. Okay, look like it's arriving. I'm not sure just about the timestamp. Yeah. Okay. I think everything is fine. Let me do a couple refreshes here. Come back to the Stream Analytics. Start it successfully. Okay, no problem at all. Cool. Come back to the SQL. Yeah, so new information arriving here. Okay, so I think everyone have knowledge about how to connect the Power BI to the SQL database, but it's really simple. So what we need to do is basically get data, and we can just go more here. And we can come for database, and we can just select here SQL Server database. Here we're gonna just pass the SQL Server database, the connections to your server, your database, and just click OK. So as I said, the Power BI here is like, it's playing the main role, but it's a simple role. So he's just getting the information from there, and it's up to us to build a nice dashboard so that we can just deliver this to the customers and they can have the better vision and do analysis like predictive analysis using this information. Let's just check now if it's refreshing. Okay, just waiting, loading. I'm expecting to see new information here. Let me order by this column. 1 second. Yeah, so the information from today is here. Let me just do a simple filter here just to us be able to okay, yeah, so we have everything here. So basically we'll have here that there's almost the same map that we have inside of the IoT Central. We have the couple informations like, for example, what's the current information of the truck state, so it's returning to the base. If any event happened, if the content stated, so we can see that the truck number 1 is returning to the base, it's empty, the cooling system is on. Here we have another observations like the amount of events by cooling state, so you can see if the truck is having any problem with the truck. Type of event, so if it part of the time, if it's in routing, if it's returning, if it's ready or not. So you can do a lot of analysis from here of the point of view, the business perspective. There's a lot of aggregated information that you can use in here and improve your business using this information. For example, truck position by content state. For example, part of the time the truck is full, which is good because it's always in road. So what's going on with my trucks? And here you can just filter by this for type of truck is, and you can get here by date, and here you have the truck log trace that can do more and more things. I think that's it. I think I'm open for questions right now. If anyone will have any questions related to the old solution, just hit me and let's check it out. No questions, guys? Alex, I think there's no questions, yeah? Alex, you there?
Hello.
Yes, you there?
Yeah, I'm good, mate. You've got a bit of time if you want. I was gonna get Dennis on soon, but just see if you've got any questions on the Q&A.
Okay, yeah. So okay. Basically, I'm leaving here some resource. For example, if you guys want to get started with the IoT Central and create your first IoT Central app, or how to export this, it's here some content. There's some links, and I can send this to the chat as well.
Okay. I can't see any questions for you on the Q&A tab.
Okay.
Dennis, are you there?
I'm here.
Okay, cool. 1 second. Are you all right to end your content, please?
Yes.
So thank you.
Thank you, Alex. Thank you, guys. If you have any questions, just return the chat.
Thank you very much. If you stay on a while, there might be some questions coming filtering through on the Q&A.
No, I'll be here. Yeah. Okay. Thank you.
Dennis?
Okay, so I can start?
Yeah, start your video, please.
Okay.
Okay, and your content? And Dennis, yeah, you should get that's perfect. If you can just move me out of the way, that'd be great. Yeah.
Okay.
Over to you, Dennis. Good luck. Thank you.
Thank you. So, good evening, everyone. Thank you for attending this session and this user group meeting from the user group in Manchester. My name is Dennis Torres. I'll talk about the Power BI Data Flows, how to achieve a self-service ETL using the Power BI Data Flows. I'm a senior software developer I'm sorry, this slide is not updated. I'm not working at Ascent Software anymore. I'm working at La Poca Gaming here in Malta. I'm a trainer, Microsoft trainer with some Microsoft certifications and the user group leader of Malta Data Platform user group. We usually have lots of technical content on our website, maltapaas.org. Here you'll find my contacts. Feel free to keep in touch, add me on Facebook, LinkedIn, Twitter, and I'm always sharing lots of technical content. So, what we will talk today? We will talk about the Power BI evolution since the conception, then when it was a newborn, the Power BI childhood and youth. We'll talk about CDM folders, on-premise data gateway, and then from this point and forward depends on the time. We can talk about refresh shadow and save on CDM folders. I'm not sure if we'll have time for all this content, but the most important is that after talking about Power BI evolution, we will make a very interesting demonstration. I'm sure you'll like that. So the Power BI evolution. Let's talk about the conception of the Power BI, how Power BI was created, how was the conception of the Power BI. It was created inside Excel. Power BI came from Excel. It was created inside Excel. Power BI started as a set of add-ins in Excel. We had Power Pivot add-in and other add-ins we could use inside Excel that did the Power BI work. Later, it became a newborn, and we got the Power BI as a separate product from Excel. And we start using Power BI Desktop to create PBIX files and start publishing these PBIX files to the cloud. What exists inside the PBIX files? We have the ETL. ETL is the acronym for extract, transform, and load. We use the Power Query, what we call Power Query in the language M, to make the process of ETL, to extract data from some source, transform the data and load into Power BI. We have the model. It means that after the ETL, we need to model the tables that we are generating inside Power BI. We create what is also called a semantic model, but I will not go in details on this definition. We can create measures on the model. We can make many definitions for the columns that we are importing from the ETL. All become a model definition inside Power BI. And finally, we have the report. We use the data in the model to build the reports in Power BI. Reports and then dashboards. So, when Power BI had just born, we had all these inside a single environment, inside Power BI itself, and we could publish it to the portal, but we most used Power BI Desktop. So we built everything together, and for us it was everything the same. We didn't mind too much about the difference when we are making the ETL, when we are making the model, when we are making the report. When we publish, Power BI was already publishing the dataset and the reports as two different objects. But this was not enough. Enough for what? Well, we had all this inside the PBIX files. The Power Query, the ETL made by Power Query, and the tabular model made by Power BI, by the Power BI modeling features. All these were inside PBIX files, and it is still inside PBIX files today if we would like so. But what's the problem? The problem is the reusability. How can I reuse something that I built before? When we start growing our models and growing the use of Power BI inside our company, we start to notice an usability problem. For example, most models need a data table, a table with data information, with lots of data information. This is a good practice in most models. But once we built a data table in a Power BI file, how could we share this with other Power BI files? We couldn't. We couldn't share. And that was a problem. How Power BI would become an enterprise tool if we couldn't share and break the development and reuse the pieces we were developing. So it came the childhood of Power BI. That's when we got the Power BI Data Flows. The Power BI Data Flows break a bit more the content of the PBIX files. So by breaking a bit more the content of the files of the PBIX files. Hello? So continuing, by breaking the content of the PBIX files, the Power BI Data Flows allows us to reuse what we are creating, and it becomes more enterprise scale product, more enterprise scale product. This is the PBIX file, so the Power Query ETL becomes a data flow. We can create the ETL using the data flow inside Power BI Portal. And the tabular model becomes a data set. So this is the difference between data set and data flow. Before the existence of the data flow, we saw everything as one single element. But now we break both and we see two different elements. Data flow is the element responsible for the ETL, responsible for get the data from the source, extract the data from the source, transform the data, and load for us. Then we build a model, creating relationships, creating measures, configuring the fields, and so on. And this is the data set. So we have now the data flow, the data set, and the reports, all the three objects. And this enables a great reuse of what we are building. Let's see an example how this becomes way more enterprise scale. So we have this database, these data sources. Many data sources available on our environment. Since these data sources many times are on-premise data sources, we may need the on-premise data gateway to get this information, to reach this information. So the data sources will be connected to the on-premise data gateway. And we can have multiple gateways on multiple sites of our company, and so on. Then we will have the data flows. The data flows will be responsible for the ETL, the extract, transform, and load process. How the data flows will reach the data that we have on-premise through the on-premise data gateway. Through the on-premise data gateway, the data flows will reach the on-premise data. And each data flow can use one different gateway, no problem with that, but the data flow needs to use one single gateway. Can't use the same data flow, can't use two gateways. But then we can create many data flows. Each one can get data from a different gateway. When getting data from a gateway, then can be getting data from different databases, because on each gateway there are many databases available to be reached from that gateway. So we could get data from many of these databases. And then we get the data flows. Let's imagine that we start creating one data flow for each dimension, for example. The data flows, they will make the refresh of the data. This means that they will be responsible to go to the source and identify if there is new data in the source and get the data. They will be responsible to make the refresh. But some details here. Since the data flow is responsible to make the refresh, this gives us some guidance about how we will break the elements, our objects, our tables, among the data flows. Will we create one data flow for each table? Well, we can create one data flow for each table if we would like. This would create, let's say, a maximum amount of reusability, a maximum possibility of reusability. But we can group the tables on the data flows according to the refresh schedule. If we group the tables according to the refresh schedule, so we will break the tables according how often they need to be refreshed. Tables which need to be refreshed once a week will be on one data flow, scheduled to run once a week. Tables which need to be refreshed daily will be in a different data flow, scheduled to be refreshed daily, and so on. But since now we have data flows, we can create data flows over the data flows. Yeah, we are talking about data transformation and self-service. Let's say the first three data flows got the data, the tables from the source database. But are these tables using the format that the final user needs? Maybe they are, maybe they are not. So they may be good for some reports, for some data sets, and they may not be good for other data sets. They may need further transformations. And then we can create a data flow from a data flow, creating more transformations, creating a net of data flows, transforming the data according to the need of the user. Mind how this become an enterprise scale solution, because when we are talking about breaking things and allowing the user to get something that is already set on the ETL and transform a bit more, we are talking about breaking this among company departments, for example, company branches, company departments, and so on. So this data flows can be offered to company departments, and the company departments can create more data flows over the source data flows in order to reach the format of the model they would like to use. And that's what we are calling self-service ETL. When we call self-service ETL, the root concept is that the user, the final user, would get his own data and be able to build the reports and the dashboards and so on. And everyone knows that a business user, when we talk a business user, let's imagine a CEO, will never do that. Never. Will never do that. So when we talk about self-service ETL, we are not talking about only these final business users. We are talking about spreading data among a huge enterprise company. Let's imagine a company is spread among many continents. How a central IT department would would be responsible for all the needs the entire company has. It's impossible. So a central IT department could aggregate and create an initial aggregation for the data they need centrally. Then it offers this data for regional departments. For example, regional sectors of the company, one for each continent, for example. And then these regional areas can transform the data a bit more for the format they need and offer this transformation further down to a country level department and so on, enabling us to have an enterprise scale system that will allow every department in the company to get data from other departments offered by other departments and transform this data, make further transformations of the data, and then create the report. But before the reports, we create the data sets. Here, these images are about the data sets, and the data sets can be based on a single data flow. I can create data sets from multiple data flows. And I can even mix data sets with data flow sources and even a direct source, like directly from the database, for example. We can do that. It's interesting that especially in this last case, we will have a small ETL inside the data set. We still will have a small ETL inside the data set. Then we will have the reports. The reports are able to get information from the data sets. How the reports get information or from data sets or from data flow, this is in continuous evolution. The final stage was not reached yet. If we consider a few months ago, the reports were able to get data from only a single data set. We could not get data from multiple data sets. But then this changed and we can combine multiple data sets. And this is still evolving. So with this scenario, these objects broken down on the Power BI portal, we are able to create a self-service enterprise scale solution. So we would not only use Power BI for our final users, we would really create an enterprise scale BI solution using all these objects offered by Power BI. Let's see the demonstration about all this. Let me go to the clouds. My Power BI is here. Sorry. I already have one workspace here. I was making some tests with the workspace Manchester, and I will delete the workspace to create again. Delete. Okay, workspace Manchester doesn't exist anymore. Data flows don't work correctly on my workspace. I hope I'm not delayed with this information. Maybe in some update they updated this, but when they were created, they were not made to work on my workspace. So I need to create a workspace. The idea is that we will build workspace. We are talking about an enterprise scale solution. We can't put everything mixed in a single place. So each area, each sector of the company needs to have their own workspace inside the Power BI solution. So let's create the Manchester workspace. And here it is, the Manchester workspace. Now, I need to get data from my local database. I will get data from my local database. So I have locally here a virtual machine called work VM, and this work VM has some databases. Advent Works 2016, DW 2016, and so on. So I'll get data from this VM in my local laptop to the Power BI portal. How I will do that? I will use the on-premise data gateway. Oh, but then we will need to keep this application open on our machines. No, this is planned to be a server application. I have it open here to demonstrate the on-premise data gateway, but you don't need to keep the application open. Let me zoom it for you. Zoom. Okay, and here on the surfaces we have the on-premise data gateway. It's a service. It will be on the Windows services, and you control the start and stop of the gateway there on the Windows services. That's it. It's a service install and can be installed on a server. Doesn't need to be on a user machine. Not only doesn't need to be, it shouldn't be in a user machine. Let's say like this. It shouldn't be in a user machine. So I will start creating a data flow. Oh, sorry, not yet. Not yet. Before I show the gateway locally. This is my local gateway. How Power BI knows that I need to access the local gateway. How Power BI knows something like this. Simple. Here on my Power BI environment settings, we have the option Manage Gateways. This kind of task is an administrator level task. administrators will manage the gateways. And administrators, Power BI administrators who are able to manage the gateways, they can delegate gateway administration among the tenants. They can delegate to other people to administrate their own gateways. Again, we are seeing an enterprise scale solution. So there is a level of delegation among departments and sectors of a huge company. And here we see data sources created inside this gateway. When I create a data source, I just give the connection information for the data source. And I could here create a new data source, add a new data source. And for each data source, I can define here who are the users, the Power BI users who have permission to access this data source. And when I define the data source, I'm defining the authentication method for this data source and even defining connection information for the data source. So the users in Power BI who will use a data source, they don't need to have the connection information to the data source. The gateway will fill the connection information. They have access to the gateway. So we have here multiple level of permissions. We have the data source on premise, which has an authentication method. But the authentication method is used by the gateway to access the data source. And then the gateway pass forward the permission to access this data source to users who doesn't know the connection information to the data source. So we can distribute the access to this data source among the company. And then we see how this works, now finally creating our first data flow. Let's analyze the options. Define new entities. This will be a new data flow. Basically a new data flow, it comes with the name define new entities. Microsoft thought it would be better to use the name entities, but we are creating a data flow, and each data flow can have many entities. Link entities from other data flows. I mentioned about, and I showed on the PowerPoint, you can create a data flow over other data flows. So you can link an entity from other data flows and then get other entities, mix them, transform them, and create something new. Then we have attach a common model folder and import a model. It is using the name model, but the name model, I would say, is a bit misleading here because it's not a model, semantic model with the tabular model. It's a data flow model. Basically, we will be working with many workspaces. We can export one data flow from one workspace and import in another workspace. The model is a JSON file, so we can import the data flow model. Basically, we are importing a data flow. We can transform a data flow in a file, in a JSON file with all the definitions of the data flow and import it back using the import model. The CDM folder requires more explanation. I will summarize this saying that this feature here, the CDM folders, allow Power BI to share information created from other products. I mean, you have other products for ETL. For example, we can make ETL using Data Factory. We can use Data Factory to make ETL. We can make transformations using Databricks using Spark. We can have many other sources creating data. And this CDM folder is a way to link Power BI in a better way to link Power BI with these tools. If time permits, I'll talk more about them later. Let's start with our new entities. So our new entities, I'll start with SQL Server, and I need to input connection data. Yes, I need to input connection data. Well, when I was showing information about the gateway, I was a Power BI administrator. Now I'm a regular user in a department who wants to get some data to build a report or something like that. I don't know the details of the gateway. I don't know anything. But I need to have two informations that someone gave to me. I need to know the name of the server which holds the data, work VM, and the name of the database that I want to access, Adventure Works. Notice I have Adventure Works on the gateway. So when the name of the server and the database matches, it brings to me the username and password. And I don't know the username and password, and I don't need to know because the gateway filled this information for me. What I need is to have permission to access the gateway. If I don't have permission to access the gateway, this would not happen. But it's not the Adventure Works I want to access. I want to access the DW 2016. And again, we get a match and we have the authentication information about the database. And next. So it's loading information from the database on my local VM, and we'll show the information here in the Power BI portal. Here is the information. So first I'll get information about geography. The geography here. Then I choose to transform data and make some transformations inside the geography. Here it is. And now the transformations here are not important for what we are talking about, but what I will do just to show that we can create the transformations, I will just remove some columns that are not needed, like the columns of names in different languages, Spanish and French. I'll remove these columns, they will not be needed, or not remove rows. Remove columns. So the remove columns is included here. Well, you already used Power BI. You know these steps because this is the same as Power Query used inside Power BI Desktop. It's absolutely the same. It's so the same that we have the advanced editor. We can also open DM script here. We can open DM script here. We can customize DM script here. Anything that we need. Okay. So we built the geography. Okay, save and close. The name of this data flow, I will call this data flow geography. The data flow contains entity. One single data flow can contain many entities. So this data flow is called geography, and the entity inside the data flow is called DIN geography. So created, and immediately Power BI suggests that or I schedule a refresh or I refresh now. These are possibilities. Let me get back to the first screen. Here we see the data flows, and they can ask the refresh now. It will be refreshing while I create a new data flow. Let's create another one. Again, I use add new entities to create this new data flow. Add new entities and SQL Server database. Again, work VM, Adventure Works DW 2016. Next. Now I will select two entities. I will select the customers, DIN customer, and DIN product. I will select these two entities, DIN customer and DIN product. That's it. Transform data. Okay. Again, I'm on DIN product. I can simplify things, removing some fields that I don't need. By the way, it's a good practice that we keep only the content we need. And this explains more what I'm calling about an enterprise scale environment. Many people could be confused. Oh, let's create one data flow for each table and that's it. Nope. Because the purpose here is to get the information that you will need for the data set. So I can start creating a data flow for DIN product. Maybe this DIN product will work for some data sets, but maybe it will not work for others. Maybe it has too many information for others. So we will restrict the information the maximum possible to achieve a better performance. I will not go too deep about this, but I just mentioned that yes, I can strip the information as much as I would like, because I'm minding about the performance of the final model because I'm on a self-serve tool. And many people would argue, oh, what about the idea to have a central model? Well, the idea of having a central model is the idea to have a data warehouse. I'm not getting this data from the production. I'm getting this data from a data warehouse. If you are getting the data from the production, you are getting unreliable data, that your data is not trustworthy. You need to have a data warehouse. We need to have your work to build a data warehouse first, and then spread the self-service idea using Power BI from the data warehouse. And the users will be able even to get data from other sources which are not in the data warehouse. They can. But the idea of having a central model, a central point for the tools involves creating a data warehouse. So when I'm working with the data flows and with Power BI, I don't care about a central source of the truth. I care about the performance of my model. So I exclude what I don't need. I just cut out because that information is on the data warehouse. If someone else needs that, it will go there and get it. So I will save. Now I have a data flow with two entities. I have two entities inside this data flow. The entities are called in customer and in product. And I need to give a name for the data flow. Let's call the data flow customer products. Why I'm putting these two entities together? The reason that makes me put two entities together is if I know these two entities will have the same refresh schedule. They need to be refreshed once a week or once a month or something like that. They will have the same refresh schedule. So I put them together on the same data flow. And I will start the refresh of this. Oh, sorry. Let me stop this. The refresh will fail because I forgot one small detail. We are talking about an enterprise scale product. There are many more details here that I will not have time to explain and go deep on them. For example, security. There are many details related to security, which are in options, project options, that need to be planned. In this case, I'll just click this checkbox. This checkbox allows combining multiple data sources. I'm combining two different tables. The data flow think they are multiple data sources. So I'm allowing the combination of multiple data sources. And this need to be very well planned in relation to data security inside the company. And Power BI has the features for that. Power BI has the features to deal with that, but that's not our focus today. So I changed the option and I'm saving again. Now I know the refresh will work. But in this case, I'll wait a bit for the refresh to be completed before going ahead and creating this data flow. It's executing, and I can see the data flows I already created. That's interesting. More than that, we are looking to the view, which is a list view, but Power BI created another very interesting view, which is called lineage view. Data lineage is a big problem in many BI scenarios, many BI environments, BI and data warehouse. The problem is where this information comes from. You need to know where the information comes from so you can know if the information is trustworthy or not. Otherwise, you may achieve a point where you have two reports saying opposite information and you don't know why. How do you track this down? Using data lineage. You need to know the source of the information. So if you have this situation and you track down the lineage of the data of that report to know where the data is coming from, then you discover, oh, this data is this way because it comes from this source, and this data is on this other way because it comes from this source. So they have different points of views because they are coming from different departments, let's say that. So we can view the lineage of the data, and that's absolutely great. Then you create a new data flow. Here, one more data flow. This time I use linked entities. I will link entities from other data flows. Since I link entities from other data flows, I don't need to give information like this. I just go next. And it will show me, it's not showing me the data flows, it's showing me the workspace. It means that if you have permission to access other workspace from other departments, you can get data from the data flow created on other departments and make further transformation for the needs of your department. Again, we are talking about enterprise scale here. But you need a good permission system because, of course, you can't have all the permissions open. You need someone managing the enterprise scale structure and managing permissions to ensure everyone will have correct permissions on the data source. But in my case, I'll get the data from the same workspace. I'll get the geography from one data flow, and I'll get the customer from another data flow. So I'm getting geography and customer, and I will transform the data. Let's see it correctly identify both tables. Mind the symbol of the table. Sorry. Wrong shortcut. The symbol of the table is different because this is not a regular entity. This is a linked entity. I can create new entities from this one, but I can't transform the entity itself. I can create new entities from this one. It's still adapting. Identify that customer is a linked entity as well. So I have customers and geography, and that what I will do is to merge queries. Let's imagine what I'm planning here. I don't want to have those tabular models with hundreds of tables. I don't want that. I don't want the tabular model with hundreds of tables. That's bad. So I will focus the tabular model on what I really need. And sometimes this involves make transformations even from the ETL to bring what I need already ready for me. That's what I'm doing. I don't want to have one table customers, one table geography, and need to manage the relationship between them. Don't want that. So I'll merge the queries as a new entity. I'll merge customers with geography, and we choose the geography key to do that. DIN geography, customers geography key, DIN geography. I don't believe. Geography key is not here. I may have made a mistake when I was transforming the previous data flow, and I didn't put the geography key. Let's fix my mistake. I need to edit this data flow, the data flow geography, edit this. Let's edit. The remove columns may be removing the geography key. Let's go directly to M to make things easier. Removed columns. Hey, I'm removing the geography key, and I don't want to. So directly on M, I exclude the removal of the geography key. Okay, so I'll have the geography key back. Yeah. Save and close. Refresh. I need to refresh the data, so I will be sure that I will have the geography key. Okay, let's be sure it's executing the refresh. Oh, it seems it finished. Yeah, it finished. Let's see what we get here in the geography. Let's make a refresh. Now it got geography key. That's it. That's what I need. Now I'll mesh queries. Sorry, there is one merge option here. I'll mesh to a new entity. I'll mesh the DIN customers with DIN geography, selecting geography key here, and it's some kind of cache for sure. It's not showing the geography key here. It's some kind of cache, sure. Let me save and close for now. The name of the data flow, I'll call the data flow customer gel. Save. Okay. Now I will edit the data flow. So let's try again in customers. Geography. Geography key. Now geography key is here, geography key, and I mesh both of them. I will give a name for this mesh. I'll call DIN customer geo. That's it. Now I save and close. Saving, validating. And here we are. And Houston, we have a problem. That yellow line is not good. What it's saying here? This data flow contains entities that require premium to refresh, including computed entities and linked entities. To enable refresh, upgrade this workspace to premium capacity. So, many of you who would face this message, and you will face this message sometimes, you think, oh, the good things can only be done with premium. Not totally true. It's not totally true. Let's edit again the data flow and check what is causing this complaint. But initially seems obvious. I have two linked entities. I'm getting two linked entities from different data flows. And it's not accepting these linked entities. It's not accepting this. So I can't link without having premium. That's not true. What Power BI is not accepting is that besides linking, you are loading the data. You need to disable the load of the data. Mind how the name of an entity with disable load became different. Here, the name became different, and I need to do the same to the other. Why I will link two entities if I'm disabling both of them? Because the purpose is not to have those entities here on the data flow. The purpose is to use their source data to build something else, something new, which is the DIN customer geo. This is the new table that we want to build, the new entity that we want to build. I don't need the other two loaded here.
Dennis?
Yes?
5-minute warning to wrap up, okay?
5 minutes? Okay. So save and close. Okay, refresh. And now I can refresh this. I can basically make this refresh, no problem with that. But without this demonstration, many of you may already be complaining, oh, you are doing this all in the portal. The portal is not that good. The usability is not that good. Can't we do this on Power BI desktop? You can. It's not the most beautiful solution, but you can. Here I have PBIX with some entities loaded. What I will do here, I will use the advanced editor to get the M script from this entity. So I can make the entire transformations using Power BI Desktop. I can use Power Query in Power BI Desktop. Then you do what I'm doing now. I'm getting the M script from the Power BI Desktop. So I'll get back to the workspace. I will create a new data flow, define new entities. It will be a blank query. Then I put my M script here. So I create the M script on Power BI Desktop and I move to here. There are better tooling coming. There are people analyzing and already building automated solutions to work with the content of the PBIX files and make some tasks with this content. And one of these tasks would be to publish a workflow. For example, get a workflow from PBIX and publish in the cloud, in the portal. First thing first, I need to fix the connection. How I fix the connection? The same. I need to match the name I'm putting here, which I name the gateway will identify. Then I select here the gateway, and next. The first message may be scary. Please specify how to connect. How am I connect this? I don't have the login and password, but when I click configure connection, the gateway will already fill the connection for me. I just need to click the button. I just need to get there and click the button because the gateway filled the connection details for me. Then I'll call this query fact internet sales. Save and close. Let me give a name for the data flow, internet sales, and ask for the refresh. That is it. Now I'm going to Power BI Desktop. Let's wait for it to open while this last one is refreshing. So, get data. I'm starting from the zero on Power BI Desktop and I clicked on get data. That's it. Load. It's incredible how our machines become slow exactly when we are making a presentation. It's incredible how this happens. Data flow. Here. Power BI Data Flows. So I'll get data from Power BI Data Flows. It's asking me to log in. Oh, sorry. Connect. So we can choose here the data flows that I will get. No, not Malta, sorry, Manchester. So what we will get? I'll get the internet sales. I'll get the customer geo. And customer products. I'll get products because the customers I should have got from customer geo. It may be refreshing, not sure. I need to check where customer geo hasn't appeared there. So let's use load. So in order to build my report, I'm getting data from multiple data flows, which are on my PowerBI portal. So we can create an entire net of data and objects being transformed since starting from the data warehouse. Our departments can create their own transformations on a hierarchical level inside the company departments, sectors, branches, and so on, allowing the company to spread the data and provide us an enterprise scale self-service BI solution. One failed. The one which failed is the customer geo. It's here. It's here. It's refreshed. The customer geo. So customer geo is here. Seems fine. Save and close. It was not showing the fields before. Now it's showing the fields. I will ask a refresh, and let's get the information again from the Power BI. From the Power BI desktop, it's refreshing. So what we saw today was the evolution of the Power BI, how Power BI started as simple add-ins inside Excel and evolved by adding more features and features that brought Power BI to a point where it is now an enterprise scale product. Power BI is already an enterprise scale product without these features. And just to be complete, I can get a Power BI data flow. And get the customer view that was not able to get before, and then I will have customer view here. So I'm creating a totally custom model. I'm getting the data flows. The data flows are responsible for the ETL, and when I'm getting the data flows and put them together, I'm creating a model. So I'm creating a custom tabular model, merging data coming from different data flows. So here is the model, 3 tables in the model. It identified relationships, already identified relationships, and that's it. There are more to be talked about this. I said probably the time would not be enough. Let me just mention what exists beyond. I was talking about Power BI childhood. I consider the data flows about being the Power BI childhood. Then the Power BI youth is the ability to share the data with different tools. That's it. I'm completing. So the ability to share the data with different tools using CDM folders is a next step in Power BI, a next level in Power BI, and now coming from the data flows. So I hope I have improved the point of view you have about Power BI. I hope I have gave you a good idea of how Power BI can be used in an enterprise scale environment using the data flow, creating a net of data flows. And please comment on the question and answers and on the chat. Comment what you think about. I would love to hear what you think about. And let's see your questions. Are there questions, Alex?
We've got one question.
Yeah.
We've got one about, it's about drill through in Power BI. I've used the same column in drill through for 2 different charts. And for that, I've made 2 different pages. So while drill through shows me 2 options, can I restrict it as per my need?
The drill through is showing 2 different pages, right?
It's showing 2 different charts that I've made on 2 different pages. Yeah.
Yeah. The point is that the drill through usually works with the user right-clicking in something. I need to remind about this to be sure what I'm saying, but I'm quite sure it's possible to create a button. You can create a button, create an hyperlink to a specific scenario, and link the button with that scenario, forcing a drill through. When the user click on the button, then you could go directly to the specific scenario you would like. But that was not the main focus here. I may not be with the correct answer in mind. If they need, they can email me. Let me put the contacts here. They can email me, keep in contact. Will you publish this content, Alex? I provide this content to you. We will publish.
Yes, I will indeed. Yeah.
The PPTs, files.
Share your slides from yourself, Victor, and Alan tonight. So yeah, we'll be sharing the slides. So thank you very much, Dennis. Really appreciate your talk tonight. It was really, really good. Also, thank you to Alan. Thank you very much, Alan.
Thank you for the invitation.
You're welcome. Victor is left us, but thank you very much to Victor for a fantastic talk. If anyone wants slides, please do get in touch. As you can see from my screen, we've got Isabel van der Kamdenhout and Michaela Onverova. They are joining us in 4 weeks on Thursday, the 27th of August. So hope I can see you all then. Please do RSVP. It's open on the meetup, and I'll be adding more information in regards to both their talks. So thank you very much to our 3 speakers this evening. Thank you to everyone that's been tuned in, and I'll see you very, very soon, and enjoy your evening. So thank you, guys.
Thank you. Enjoy your evening too.
Thank you, Dennis.
Bye.
Thank you.
Goodbye.